Hi everybody. Alright, so one of the first things I want to address with this video is some things I've seen either in the past or maybe in class. And the first topic I want to hit is regular numbers versus exponents. What I often see as a mistake, which I've been seeing on a few people's papers, is that we've learned all these different shortcuts for exponents, but some people tend to over-apply them. And what I mean by that is they'll start to apply the exponent shortcuts to the regular numbers in the problem. And we have to remember all the properties, all the shortcuts we've learned only deal with the exponents. So for example, let me give you this problem. 4x to the third times 2x to the eighth. Now a mistake answer I will often get on this problem is this. So take a look and see if you can spot the mistake there. All right. So basically what this person did was they applied the exponent shortcut correctly. X to the third, x to the eighth. You're multiplying, so they added the exponents and got 11. But what they then did as a mistake was that they tried to apply that same shortcut to the regular numbers, 4 and 2, and they made it 6, which is incorrect. Okay, the way they want to be thinking about this problem is more like this. 4 times, and then I'm going to do commutative property. I'm just going to go out of order. 4 times 2, this number and this number, and then x to the third times x to the eighth. So now what this looks like is 4 times 2 as regular numbers. 4 times 2 is 8. Exponents, though, x to the third times x to the eighth, we add the exponents, so it's 8x to the 11. So you can compare this to the mistake answer here. These are the things we got to be careful about. Is just don't overdo it with these rules because they only apply to the exponents. Regular numbers, just do them as you normally would. Same thing on a problem like this. Okay, I could see a mistake answer here being this. 9n to the third. Once again, see if you can make sense of it for yourself. What mistake just happened there? All right, well, what happened is this. N to the fourth divided by n to the first. That part's right. We subtract the exponents in a division problem. But 9 is incorrect. Okay? 12 divided by 3. These are normal numbers. So once again, you kind of want to separate it out like we did over here. You might even want to look at it like this. 12 divided by 3 as normal numbers is 4. Then we can do this part. N to the fourth divided by n to the first. The shortcut is to subtract the exponents. So that part was correct. N to the third. 4 n to the third. Okay, so that's the number one thing I want to get across to you guys. Is I see this all the time. Is people overdo it with the shortcuts, not realizing that the shortcuts only apply to the exponents, but it doesn't apply to the regular numbers, 2, 12, 3, 4, and 2. Okay, so be careful about that. Okay, I want to do a couple more like this, but this time we're going to take a look at negatives. Okay, so we're still looking at regular numbers versus exponents, but again, this time we're taking a look at negatives. All right. And again, a mistake I often see is the fact that negative exponents is a completely different animal from negative numbers. Okay, negative exponents we've learned is this whole idea of flipping to the reciprocal. Okay, but people confuse that with a negative number. And again, just like in the last couple examples, there's a difference between what we do with exponents versus what we do with regular numbers. So for example, let's do this one. Negative 2 m to the negative fourth. Now, the instructions in the book or the quiz or what have you will say simplify. Now, in this case, what we want to simplify is that we don't like negative exponents. Negative numbers are okay. They're just treated as regular numbers, so a negative number is fine. But we don't like negative exponents in our problems, partly because we just can't do the math. We know how to do positive exponents, but you can't compute a negative exponent the way it is. All right, so the way this problem looks is, once again, the regular number, negative 2, is fine the way it is. It's okay to have a negative number. So we'll just recopy that. But we don't like negative exponents. So this part of the problem is where we use our shortcut, which was to flip it to its reciprocal. 1 over m to the fourth. In the process of flipping, the negative disappears. All right, now we put this all back. I'm going to change negative 2 to a fraction. And if I just multiply across, negative 2 times 1 is negative 2. 1 times m to the fourth is just m to the fourth. Okay, and this is the simplified answer. Once again, it's okay to have negative numbers, but we were just trying to get rid of that negative exponent, which means we had to change the problem to this. Okay? Now, same thing over here. I've given problems like this where people think they're supposed to flip something because they see those negatives. But that's not the case here. These are negative numbers, not negative exponents, so that flipping rule doesn't apply here. Okay, so in fact, I'm going to do this one like a different problem I did, is I'm going to just kind of rearrange this. I'm going to use the commutative property of multiplication so you can better see it. I'm going to put the negative 3 here times, and I'm going to put the negative 5 here, and then x to the 4th and x to the 8th. All right? So now when I do this problem, I'm going to treat my regular numbers as just typical regular numbers. Negative 3 times negative 5 is positive 15. We don't do it any differently from what we've done in the past. Okay, and in this case, our exponents are positives. X to the 4th times x to the 8th is x to the 12th. And there's our simplified answer. Okay, no flipping involved because these negatives were just regular numbers and not negative exponents. All right, so again, just some common mistakes that I see in class or in previous years, and those are the things we have to be careful about and work on today as we review